which if I can find the little icon for it. Here we go. Here we go. And I'm going to say present a view and start from slide 1. Okay, so you should be seeing something that says program will begin shortly, which is true. I just want to do sort of a preamble that I think we've all been wondering about what comes after FMP 12, looking for scalability and network performance, and also browser delivered and managed content. Why MongoDB is the question I want to answer today, and I think I will convince you that it's a very powerful and good choice. This is what data in MongoDB looks like. It's stored as JSON objects. This is a JSON object that has some family information, contact information, email addresses for a family, and it's for my youth sports client, and they have players in their families. There's an array of players with attributes of the players, and then sorry, I don't know, I keep throwing my mouse and it does the wrong thing. On the other hand, so this is a hierarchical structure with a parent and an array. If we were doing this in FileMaker, we're more used to looking something like this, which is player information and then related family information, and we look at it this way. So why are we doing MongoDB? I mean, after all, ESS almost works, so wouldn't MySQL or something else be a better transition? Why put us through all this when we've only just recovered from FP7, in my case? I want to hope I meet your expectations for this session, and I'm trying to follow a standard set by an Australian comic called Hannah Gadsby, who has a Netflix special called Douglas. And she begins by announcing what is exactly going to happen through the rest of her session in order with the structure down to what the last joke is going to be about, and then starts going through it. And it's so funny and so absorbing that you don't notice, in fact, except when she mentions it, that you are following her agenda. So that's the standard of entertainment that I'm trying to aspire to. And there may be a couple of jokes in here, and they are, I must admit, at the expense of Draco. So if you would find that offensive and wanted me to warn you in advance, you can mute until they're over. But they're the kind of jokes based on a loving, decades-long acquaintance. The kind of jokes you might tell at someone's funeral, in fact. But if you've led a good life and faithfully followed the tenets of the Fourth Church of Normal Form, and I, for one, have done that, it is time to think different. This is the agenda. We're going to go through some basics. A first look of MongoDB, how it's different, how it organizes storage, and so on. Then we're going to look at ways of organizing our data in MongoDB, which is basically data models. We're going to look at accessing MongoDB data from Claris Pro, and the answer is yes, you can, although there are some limitations, which we'll talk about. We're going to look at performance, comparing data stored in MongoDB, MySQL, and Draco, doing a standard database maintenance task, which is removing duplicate records, because people sign up on a public website and just create multiple IDs for the same people. And then we're going to look at resources, some basic learning resources, and also some client-side tools for working with MongoDB, 3 of them actually. One of them I'm going to demonstrate. So let's look at the basics. And then we're going to go through managing related data with MongoDB, accessing MongoDB from Claris Pro, Sorry, we're going to go to the basics first. What am I doing here? I'm having trouble with these transitions. The basics, this is what we're going to talk about. Okay. MongoDB stores data as JSON documents. So rather than as a record, you would have a JSON document. And this is a document describing a movie, and it has a plot. It has a series of genres to which it belongs, and it has an array of cast members, and it has a title. So a document's a JSON object. A collection, we would think of it as a table, is a group of documents. And for many applications, all the documents will have the same structure. All the documents in one collection will have the same structure, but that's not a requirement. Newer documents elements can be added on the fly. So the data structure or the schema is stored in the data itself. It's not a separate structure. A typical SQL-like DB has data tables, rows with columns, usually has join tables for many one, many, and many relationships. Sorry, it'll have a join table for many relationships. And a pre-specified schema must be in place. So to store data, a data object with a particular name or type, you have to put it in the data structure first, and then you can enter data. With MongoDB, we have collections rather than tables, documents rather than rows and columns, rows with columns, no join tables usually, on the fly schema evolution. Now you can use a MongoDB collection as a join table if you choose. It's not particularly efficient. And MongoDB developers I've spoken to say that if you really have to have that kind of structure, and this will seem strange, you're better off using a SQL tool like Oracle or MySQL. When you create a database in MongoDB, the system automatically creates at least 2 more copies of the data called nodes, and those are referred to as a replica set. If the primary, and this is how it works, basically there's a primary node and 2 secondary nodes. Your application usually reads and writes to the primary node, and those are continually backed up to secondary nodes. And you can also, however, read data from one of the secondary nodes. So if you have data warehouse type applications and want to say use Tableau to read data in high volume, you can run that on the secondary node and not load the primary application node with that work. I'm actually going to say a little more there. This is a simple structure. You can have a lot more, and you can have structures that replicate themselves around the world and have availability in multiple locations. It's pretty impressive, actually. One thing to note is if the primary node stops working, a secondary node can automatically be promoted to serve as the primary node, and a new secondary node is put in its place. I think that can be made completely automatic. Boson or Beast, I'm going to call it Boson. I don't quite know how you're supposed to pronounce it. Documents present as JSON strings, but are actually highly indexable. They're stored as binary objects in the Boson format, with indexes stored in separate files. So, in fact, as we go a little clearer, the JSON you see is just like Plato's shadow on the wall of a cave. The data is stored in a highly structured format, and there's a link at the end to a Wikipedia article about how that format is specified. Importantly, if you run a query that only uses indexed fields, that can be performed completely using the index. Very different from Draco. So a multi-node structure can be stored in a single document, and I'm giving you the same example again. The data and sub-elements of it can be retrieved and rendered very quickly. So imagine you have something as complex as an Amazon product page. and you wonder why those come up so quickly. They're not using relational tools to pull up all the sub pieces from a hierarchical structure. It comes up in one data object. Here's a simple example. A person, gender, age, and an address sub-object, so that you can quickly get not only the person saying you don't have to look up an address in another table, it's embedded. That's called an embedded sub-object. But the first thing I think a typical traditional FileMaker or even a SQL developer is going to ask is, what if that address is for a business location and is shared by many people? Now, MongoDB offers one technique, and supposedly, obviously, I meant to say this before I hit the button, the address changes for all of them. They can be used, there's a tool called DB references can be used to define relations between connections. And so here we have the person object, and you see that there's a ref called address home, and it has an object, there's an address object, but you see that it's contained in a sub-object, which has a name, an object ID, which is a universally unique ID, in another database. And if that actually points to a specific object in a specific, document in another database. And so, and it can be loaded with this one. Now you do have to script the loading from a, you can't, it doesn't just come automatically like it might in a related, in a calculated field in FileMaker, for example. I'm not going to say much more about anything more about the DB references. They are very powerful and they can be used to cross multiple installations and multiple databases as well, and they're very sophisticated linking of information. The next, we're going to talk about how data might be organized in. I'm going to talk about, when I say we, organized in MongoDB, and we're going to look at various structures that might be used. And we're going to look at something called aggregation pipelines and views, which is something like SQL views, or but not completely. And we're going to look at triggers, which are used to manage denormalized structures and manage data integrity. So we're going to look at two object types coming from this structure we've talked about already: families and players. Each player belongs to one family. An operational need is to manage players and families as distinct lists. The reason is that players individually enroll in programs and have to be given information and instructions and evaluations based on that player's membership. But for marketing and general communication, we write emails using MailChimp to families, and we select lists of families, and we mention the players in their families in those emails. And so the family with players embedded, the one we showed, the first example I showed on the screen, is useful for that. So a typical FileMaker relationship graph would have players related to families, et cetera, et cetera. I don't think, I'll just leave that up for a second or two, but that's not going to be unfamiliar to you. And we're going to look at typical MongoDB approaches. A family with players embedded, a families table plus a players with family embedded table, family data embedded table. In other words, we're going to have a families table, and then each player will have embedded in it, each player document will have embedded in it some family information. So that as soon as we see a player, we know what email address to use, what their parents' names are, what their phone number contact is. This is a youth sports database, so no contact information about the player particularly. All communication is through parent contact information. And we can also have separate families and players tables, as we might in FileMaker. So a family with a player embedded is a family object with an array of players. You see in bold there in blue. And that links to an array sub-element, which has a list of players, and you can have 4 or 5 or 6 of those if you, or even as many as you want in theory. So it's kind of like a repeating field in a way, or a set of repeating fields, but much more elegant, I think. So a family with players embedded is another way of doing it, which is, sorry, the one we're just talking about. I'm sorry. And it's very efficient for viewing the family as a unit. It's less convenient for collating or grouping players based on player attributes. And this is the second approach, to have a family's data table and then have player records with some family data embedded in it. So I'd have a player record, and then there would be a family sub-object, not an array, just an ordinary JSON sub-object. And that would be that. And there'd be one record there. So it's less storage efficient because we're family info stored in 2 collections. And it's the denormalized structure, which requires a trigger to main data integrity. But the player is the root object, so it's easier to use that collection as like a players table. Separate, third one we're going to think about is just having separate tables. Much more complex for retrieving and updating a family unit. And the normalized approach, though, is familiar to Claris developers. But it's not the way things are typically done in MongoDB. Views. From a families with players collection, we can build a virtual players collection, or a view, whose documents look like this. Sorry, I keep flipping my mouse and I forget that it takes me back and forth. There's the player information. Sorry, families. Okay, we got, this is the, sorry, I beg your pardon. This is the view we would have. It would look like a flat table with player data and family data in the same record or the same document. And that information comes from the families table. And views are created using aggregation pipelines, which are really cool, actually. A pipeline is a sequence of queries or stages applied cumulatively to a source collection. A parallel SQL might be a view based on a view based on a view. A pipeline can be saved as a MongoDB view or executed with the result saved to another collection. So one way of managing denormalization is just to run that script and do that periodically so that every minute or two your permanent copy of that view is updated. So we're going to look at how a pipeline works. This is our source data. I made it diagrammatic rather than print out the, just lay out the code itself. But our family might have 2 players. This is where we're starting. The first stage is called a project stage and strips out the family data that we don't need in this case. So a projection takes your structure and says, don't look at this, don't look at this, strip the thing down to a manageable and simpler structure, which means from this point on, we're only going to look at the things we've projected to look at, and it's much more efficient. So any query, first thing you do is project and cut down the data map, if you like, to something much simpler. Not much simpler in this case, but it could be. And then we're going to do something called unwind, which means rather than have an array, we're going to create a copy of the parent level data for each subarray, each element of the player array. So this is coming like doing a left join in SQL, where in fact, all the parent data is repeated in every record, and then you have the related data for each of it, each row. And then we're doing something called replace with, using something called merge objects, which means replace what we did have, which was just the family level data up here, with the family plus the array object, the related array. There's only one. This is 1-to-1. So it's just saying move this from being a sub object to being part of the parent object. And then we do another project, which basically gets rid of this here and leaves us with what we're looking for. And that's what we would see if we displayed that in a FileMaker table. I just want to go back here and point out that it looks very much as if we're moving stuff around all over the place. But actually, we are not doing that at all. We are just changing the logic by which MongoDB is going to read data from our collection, from each document in our collection, in fact. While we look at JSON as a text string, MongoDB knows exactly where each data element is. It's just changing the rules, the way it threads through and what it presents and how it lays it out for us. So it's extremely powerful. Sorry, I just said that. I meant to have that up while I said that. But we're not moving any data here. We're just saying this is the sequence by which the logic you'll use to thread through and pull the data out we want and arrange the result. As JSON, what it's worth, the JSON object for that pipeline looks like that. You can add this object, this element at the end, $out players with contact, and then when you run it, it will create that collection, call that, and populate it. And if you run it again, it will effectively truncate the existing object and replace it with a new set of data. And you can put indexes on that and make queries on that very quick. Queries on a view itself will work because a view looks like a collection to the end user, but they're not as fast. Effectively, if you query a view, you're just adding one more filter on the end and running the whole thing again, which is not particularly fast. Rather faster than Draco, I might point out, but not particularly fast. It takes 4 seconds to run that. Now, the data I put in there has 20,000 families and 57,000 players. So it does all that, and in 4 seconds writes out a flat table for you, the equivalent of the analog of a flat table, which is quite impressive, actually. The last one we're going to look at was families table families table. We use the one we talked about before, basically, this method, which is a families table and then the player with the family attached table. And we can actually keep building that table and update it. And we can actually use triggers to maintain that table rather than running that view and saving the result every 5 minutes. We can basically run a trigger that says, if the family's changed, update all the related player records. So a trigger can be set up to automatically update the related players when a family document is updated. So if we look here, I'm going to show you actually a movie of this. Here's the players with families and beta indebted. This purple data is from the family record. You'll notice it has a zip code, and you notice the phone number is not formatted correctly. So we don't want to correct. We might want to fix that. So I can just run a little movie here that shows us doing that. I'm going to go into Navicat for MongoDB, find that record, fix the phone number. And I'm going to just edit the zip code to something else and save that. And you'll see if I refresh, which means just refresh that page, that has all happened. And it's happened in 2 separate tables. It's happened in the family table, which I edited, and it's happened in the players with family embedded. So while it might seem that this whole denormalization process is cumbersome, in fact, you can completely in the background maintained complete data integrity over all these hierarchical and complex structures. When E.F. Codd and C.J. Date really lectured on relational databases, it was in the late 70s, early 80s, I think, we didn't have massively powerful processors that could run stuff on the back end continuously. We didn't have massively fast solid state disk drives. And so a lot of the traditional fourth normal form method of organizing data, which is still perfectly good, of course, dealt with those needs to address those kinds of performance issues. But with tools we have now, it's going to be, there's a lot of power in this. And my contacts at Cupertino tell me that FileMaker Claris are hard at work making all this easy to access with a simple point-and-click database point-and-click interface that is going to be as easy to use as our traditional FileMaker application. Unfortunately, my contacts in Cupertino don't actually work for Claris, so I'm guessing a bit there, but the tone I got at the meeting was that that is the case. So let's go to the next one. Can we access MongoDB data from Claris Pro? We're going to look at Claris Studio tables, MongoDB via ESS ODBC. They have an ODBC driver, which I'm going to talk about briefly, and using the MongoDB API, which can actually run transactions for you. So let's go to that. I created a little app running on a Windows AWS server, running in Claris Pro as a client of Claris Pro server. And it includes, I think you can see it includes, I'll just run this. I've got the same data set pretty much in Claris Studio, in MySQL, and MongoDB. Now, MongoDB is accessed by what they call the, Business Connect. I can't remember exactly what it is. They have an ODBC driver. And I've made that work as if it was a MySQL driver with FileMaker server, with FileMaker client, Claris Pro client. I haven't made it work with Claris Pro server yet. So actually to make this work, I had to create a little extra file running on this machine using that ODBC driver installed here on Windows to actually simulate the effect of it. So there's a little table in the background that's actually uses an external source to display the MongoDB data. So, and now I think we're going to look at what are we going to look at next? We're going to, okay, we've done that, we've done that, we've done that, we've done that. And oh, I don't want to do that. I want to go to the next slide. Let me do that. Oh, yes, here we go. Another movie, I think. This shows the same thing over and over again. I apologize because I'm not quite sure what's happening here. Okay, yes, it's the next slide. Sorry, I had this one repeated by mistake. Okay, MongoDB has an API. And it works pretty much like JSON-based APIs you're used to using, and you can set up endpoints. And I've set up two endpoints here. One is I have a table of potential duplicate entries in the players table, and I've got one that takes all the data out of that, and one that then reruns a query to produce that data and takes about 7.6 seconds to repopulate a table. I'm going to demonstrate it again later. But you have to futz around and create some endpoints on the back end to make this work. But once you get through it a few times, it's not too difficult. I should point out that I set up what's called an M10, I think, cluster with MongoDB. And that includes 10 gigabytes of data with 2 secondary storage locations and the primary one that we talked about before. I also pay $50 a month to get their online technical support, which is incredibly responsive and very patient and very good. And if you want to play around with it, that's $100 a month of, I think, a great value if you want to start looking at this. I also paid to have the DB connector, the ODBC driver running, which costs about $40 a month. So I was paying about $150 a month for this demo session. But it does let you look at it. Now that ODBC driver was really developed so that you could use analytical tools like Excel or Tableau, which need data in a tabular format. So it's useful. One difficulty with it is that it's read only. You can't do transactions with it. It was never intended for doing transactions, but you can use it to display data in FileMaker using SS, which is sort of fun, if nothing else. And we're going to look at exploring performance. I'm going to look at doing a basic task I think I mentioned before in MongoDB, having the backend data in MySQL and the backend data in Draco. I was going to have it in Claris Studio, and for reasons that I'll explain in a minute, I haven't done that. So here's our typical collection. We're going to look at this 2-table collection model. And we have 56,000 players and 21,000 families. My actual, the real data has about 20,000 families and 15,000 players actually, but I wanted to wrap it up in this sample data set just to sort of test things out. A task, we want to find players that may exist in more than once in the data because the same family creates more than one account. If multiple records have the same last name, gender, date of birth, and zip code, and the zip code is in the related family record, then such a duplication is the likely reason. So we want to find a list of those, put them in a temporary table, and then run some scripts to make available some interface scripts to merge those records, and where players are enrolled in programs, change those enrollment records to so they're all based on the same player, even if the player's in there twice originally. So here's the situation we have. Let me see if I run this. Oh, I've got this thing again. FileMaker, Studio, MySQL. I should have gone through and just economized on how many times I show this. We're going to find duplicate players using Draco, MySQL, MongoDB, and find duplicate players. And I think if I got the movie here, I can actually take it through this. The first one we're going to do is using SQL. Doing that in SQL, the 59,000 records, looking up family data is 1.1 seconds. It blew my mind when I saw that. Then I think we're going to, oh, that's that one. So I want the next slide. Okay, that's how it took. I apologize for not having all the slides. Okay, and I think we're going to do that. Sorry, that's not what I wanted to do. I think I have. Let me go back. I apologize. Oh, we have a movie here. Okay. Next slide. Next slide. Oh, here we go. This is MongoDB. I did this out of order. Excuse me. No, wait a minute. There we go. Okay. So I'm going to use the API here to delete all the records in this table of possible duplicates and refresh using MongoDB. Sorry, I apologize for my clutching around here. So it's transferring data. It's taking 6.9 seconds, which is not as fast as SQL, but it's not too bad either. And the next one, I think I'm going to do a Draco in a minute. I think it's the next one, actually. Yes, this is going to be Draco. And I would like anybody to volunteer an estimate of how long this would take with using regular FileMaker data. This is point of PSOS. It's running on the server every time. Does anybody want to unmute and make a guess?
15 seconds.
Anybody else?
I'll take the over on that at let's go 25 seconds.
Okay. The way I did this was to first search players without doing the lookup to find candidate duplicates based on gender, zip code, and date of birth. Sorry, last name, gender, and date of birth without looking at the zip code. That fills it down, and then had a calculated field in there that checked whether that family had more than one child in it with the same. Sorry, whether there's more than one family with that player existed in more than one family, and those were the potential duplicates. And then I did an export to a text file with a group by, and it re-imported to get the table. The last piece took practically no time at all. There might be faster ways to do the query. I can't think of it. This is what I call a Starbucks query. And I like to be positive about Draco. And it means that if you set it running and go out for a coffee, there's a 50% chance or better that it will have finished running by the time you get back. And this is a pretty simple example. There are ones that take a lot longer. So we're going to run this and we're going to see. You get this not responding thing on Windows when things are taking a long time, which is a bit disconcerting. I'll tell you while we're waiting, the reason I didn't do this with Clara Studio is because the only way to do it with Clara Studio data is to run FileMaker scripting bolted over Clara Studio data stores, and it simply is it's not designed, it was never designed to work that way, and it's pretty slow. It's quicker to copy the data from Clara Studio into FileMaker and do it there, in fact.
So you said one of the fields that you were querying was an unstored calculation?
Okay, so I went through the players table and said, find all duplicates of last name, date of birth, and gender, and found those first. And then we want to check that they're not genuine, i.e. they do belong to different families. They're not two. You might have twins, for example, in the same family, and they're not duplicates. So you need to check that they are actually in different families. Or you need to check that they're in the, sorry, I can't remember. I did it the best way I could by then narrowing the database down first and then doing some search on a calculated field to find whether it was a real duplicate. I'll look it up and get back to people if they're interested in that. It takes 52 seconds, basically. And so this is the fundamental, and there might be ways to get a little better techniques. I tried several, actually. This, I think, is this is the performance issue that has been holding FileMaker back. And I desperately needs to be dealt with. And it looks like it is going to be, which is a great relief to me. I just hope it's soon enough. that I can do something with it for my clients. Let's look at resources. I have a I'll upload when I get out through this, I'll upload a document that has links in a PDF for all of this. Client-side tools, there's a tool called Compass, which MongoDB which provide pretty much all, not all, but most of the capabilities that their web portal does for managing your installation and setting up queries and so on and so on and so on. There's a client-side package called Studio 3T, which is looks like a typical SQL front-end management tool, but it's designed to work with MongoDB. I'm going to demonstrate that one when I finish the slideshow. And Navicat for MongoDB. I've used Navicat a lot for SQL, so I was familiar with it. So I've used that as an example. There are quite a few examples around. And educational resources, there's a very easy to read primer called the Little MongoDB book. And that's about 80 or 100 pages. It's a quick read, like 2 or 3 hours, if you're really paying attention. And it's a very good starting point to get an overview of some of the differences between MongoDB and traditional databases. The MongoDB Basics Guide is available on the MongoDB site and is a mostly readable beginner's guide. MongoDB University is a full training program, and it's excellent, and it has short courses at introductory, intermediate, and advanced levels, and includes special introductions aimed at JavaScript developers and SQL pros. There's a little article called 6 Rules of Thumb for MongoDB Schema Design, Views versus Denormalization, a blog article, SQL to MongoDB mapping chart, and the boson specification. That's a Wikipedia article. I said there would be some sort of punchline at the end, and I'm going to talk about another case study. I have a client, which is a small business based in Connecticut, performing annual inspections and certifications for medical equipment. There are 555,000 pieces of equipment in his database, and they're located, each one is located in one of 2,000 facilities spread across Massachusetts and Connecticut, some in New York State, maybe Rhode Island. Each equipment item has 2 to 10 measurements that need to be done annually, depending on the type of the equipment. So different manufacturers might make a blood pressure monitor, but a blood pressure monitor has a specific set of measurements that must be done annually to check it's working properly. There are 700 equipment types, and each has its own list of required measurements with the pass criteria for that equipment type. Each facility may have up to 300 equipment items, and a visit is set up for a specific date on or before a specific due date for that facility. So the last inspection was, say, for a facility was completed March 30th, 2021. So the next visit had to have been completed by March 30th, 2022. But so that's the due date. Often the visit's done a few days ahead of that. So you choose a particular date, somebody's going to be in that area, a technician, and will go and do the measurements. An inspection is the set of measurement results for a piece of equipment. So each visit has a group of inspections. A measurement is complete if it's been done and passed. An inspection is complete if all its measurements are complete. And a visit is complete if all its inspections are complete. And so looking down from a macro level, my client wants to know things. Are there any visits whose due date has passed but are not complete? Which without denormalization is a very difficult question to answer. When it's not a difficult question to ask, and you can answer it, but if you want an answer the same day, you need to do something. You require quite a lot of denormalization. And there's no need to look at this, but this is a table-driven structure that a SQL type or FileMaker developer might use. A customer has locations, there are visits set up, there's equipment, there's the equipment type, test profile. Sorry, I keep messing with my mouse. The test profile is based on the equipment type, is the set of measurements that need to be used. Each measurement is a measurement type, and that measurement type has a list of measurements that have to be made. The test profile says what measurements are going to be used, but also what the price criteria are. And then each inspection has a set of measurements. So all this stuff links together. And it's pretty complicated. So if I want to answer this question, I've got to start with the measurement. And the calculation of whether it's passed is based on its results. And it's got to be, you want to know the equipment type, the test profiles, and the measurement types for that piece of equipment to calculate whether it has passed for that particular test. Passed its inspection. It's that particular measurement, by the way. Is an inspection complete? It's a calculation based on the status of all its measurements. Is a visit complete? It's a calculation based on the status of all its inspections. So if you don't hard code, hard save a lot of these intermediate results on the way up, this is going to be a nightmare. Are any visits complete but past their due date? You've got to search for visits due date less than today and not complete. And that's got to go here, around here, around here, around here. So this particular customer, we do a lot of denormalization to make it work. And even then he insists on using remote desktop to get reasonable results, reasonable performance on some tasks. But what if we pull all this information for a visit into a single document? A visit has inspections, it has measurements, and you already can pull into the measurements, the pass criteria, and so on, and you can store the results. And hold on a second. And you can keep all this in one document. You can put the result in that document. You can save the pass-fail results, designations for each measurement, and immediately you can write into this visit whether it's completed and searching for whether has it going to be by its due date. It's pretty fast, I would think. Sorry, what did I? Yeah, so that's the end of that bit, actually. But you can do things, for example, like we think about this a bit. Let me go back to where I was. Presentation, play from current slide. Okay, I'm just gonna move that up to that. I don't know why. Okay, I've got to. Sorry, I'm not sharing this now. I'll put it up there again. Okay. If you think about this, I could create a view that creates this. Now, a view for one visit will work quite fast, but actually, in reality, right into the raw data collections. There's all kinds of ways this could be arranged to perform very quickly with MongoDB. It would also work reasonably well in Oracle or MySQL, by the way. But this is one of the things that you can maintain a database of visits and use triggers on the back end to track all the changes and continually update all the tables that are related to this. And it's really kind of it's kind of awe-inspiring in a way to realize how powerful this is. And when we started saying, why are we going to do all this? Do we really want all this trouble with data integrity and different structures and so on? If you can make it easy and manageable to maintain the data integrity on the back end with continuous triggers and so on and updates, and have the fastest possible way of displaying data using hierarchical JSON structures instead of related tables, you have the best of all possible worlds. I quickly just want to go back. Let me close this. And I'm going to go and take a quick look at Studio 3T. You can get a trial version of this and play around with it if you like. One of the things it has, though, is you can put in a query, a SQL query, which I'm going to select player first, player last, rating number from players, where rating number is greater than 5, and I run that query, and it generates the MongoDB shell language code for that query, which is really handy, actually, because to work it out for yourself might take quite a while. I'm not sure it's always going to be the most efficient query, but it's a starting point to fine tune. And it also explains the query performance and tells you exactly how long everything took for each stage. It did a scan of the collection, filled it down to 2.3 records, did a projection to cut out some of the fields we don't need, and resulted. So the whole thing took about 5 milliseconds, basically, the whole thing. 59,000 records. Not bad. I can make this slightly more complex. I can put distinct in here, for example. I think I've pronounced that right. And then run that again. And I look at the query code. It's much more complicated this time. And I do the explain and look at the results. It actually takes 49 milliseconds instead of 5. But it would, if there were duplicates of the players, for some reason you wanted to use it. So, it gives you somewhere to start with. So that's quite impressive. I can just look at, say, my players table and just, it's here. Looks pretty much like you'd expect. If I look at players with families with players and families with players, when I think, how do I get down to the next level? I'm not going to do that. I was going to point out if when these tables are flattened, subdata is the implicit column names for subsidiary data in subsidiary structures is the JSON path to that value. And that's can be extremely useful in a table if you're trying to then generate a JSON object to represent that data. You have the path to use in JSON set element right there in the field name. So I'm going to stop there. I'm sorry about the back and forth with some of the slides, the movies. Anyway, if there's any questions, I'd be happy to do my best.
Oliver, it's Sean. From your work so far, how do you sort of envision it being most useful in the near term? I understand Clara Studio is heading in the direction of integrating this. Is it mainly using that ODBC connection that you're talking about, or writing separate apps completely, or how do you kind of see integrating the usefulness of this in the near term?
I'm not sure whether developing a data structure directly in Mongo is going to be useful for a Claris developer in the future. It might be. I'm not really sure what the roadmap is, actually, except that they seem to be saying that this power will be harnessed by a scripting language I'm going to give you in Claris Pro. And all of this will be available for you to make work. So the purpose of the presentation was to just explore the potential of MongoDB rather than say, this is how I think Claris is going to use it.
Right. So it hasn't sort of emerged yet as to kind of exactly what it looks like. It looks incredibly powerful. It looks really interesting.
Yes, I mean, it's not something you would think of, but I mean, normally you would think of normal form data structures that Oracle uses as being, at least I did until I got into this, as being more straightforward, very powerful. And you again have views and procedures to denormalize in SQL as well. And I would have thought if you're going to move from FileMaker, where we already have ESS that works, sort of 80% of it works right, why not do that? But then when you see the power this has and what potential, I think it's a good idea that they went with MongoDB. But,
yeah, I mean, you can picture interfaces working directly with it too, which is I think where they're headed. So which would be really exciting.
I mean, if you look at the data API, for example, you could have a layout with apparent context and a couple of portals for related tables. Abstract without looking at the visual side of the layout, the way that's saying this is the data, this is kind of like a hierarchical view. And that's sort of the way it works, actually. If we use that idea of a parent layout with, portals to show the subarrays, I don't know if we've got somebody from Claris on here. Why don't you tell us what they're going to do?
So right now, for example, could you write an API query to a Mongo database and return it to FileMaker and present it? Just
I did that actually in the demo. I don't know if were you on the whole time or not?
yeah,
sure?
I was. I may have missed the detail. I mean, I saw you playing with API connections. I just wasn't sure.
You can
how that actually comes into
submit
FileMaker.
an API with a CRUD type query and make it run something on the back end, and then I refreshed it using their ODBC connector to show the result. So that's what I did, and it took 6 seconds round trip to do that complex.
Okay, yeah, that was using the ODBC. Got it.
To present it, but not to run the
To run the query itself.
I use the API for that.
Cool. It's very exciting.
I think it is exciting. I don't know if you're on the beginning. They did a partner presentation, which is very informative, but half of it was Brad Fiedel and the marketing people talking about how we're going to position stuff with developers and customers and clients again. And half of it was by Robert Halsey talking about where we're going with Claris Studio. I would have rather had it 20%, 80%, because when we have a product I can really use, then product market segmentation and strategy, I think, would be pretty easy to figure out. But having more and more nuances on how we present stuff and sell stuff on a product that's not there yet is, I find a little frustrating, to be honest. So anyway, I don't know if other people feel the same way or not.
I definitely feel the same way. I have another question that I missed the beginning, so you might have talked about it. This is Jerry Salem. One thing, the one comparison that you shows MongoDB was like particular task. It was 5 seconds, and then MySQL took about 1 second. Now, to put yourself in Claris's head, I know you're not there, and even if you were, you couldn't tell us. But why not? Like, what's the benefit of having Mongo in the background versus MySQL? Like, could they have done the same feature set with MySQL in the background? What's the benefit of Mongo?
Well, that's a very good question, and I will defer that.
Okay.
But they did say that they're going to enable SQL backends as an alternative to Mongo as well with Claris Studio, which was real surprise to me. But also, somebody raised this in the audience. I did this as raw with denormalized data, comparing like with like with like. Now, in both FileMaker and in MongoDB, you would probably write, say in FileMaker, you would run a server-side script every morning to write the zip code check the zip codes from every family that have been updated and update the players. In SQL, you'd probably have triggers in SQL that do that for you too. If the family zip code changes, it would just keep the players up to date. And in MongoDB, you probably wouldn't use this totally normalized structure in the first place. You'd probably have a hierarchical JSON structure and use triggers in the background. So if you're using, I haven't run this on the same table with the zip code included in MongoDB. I could do that. I would probably be very close to the performance of SQL if you did that. But it does amaze me how fast SQL can do things. That's just a 2-table hop, but you could probably add a 3-table hop in the view, in the query. That would take it even longer in Draco, but SQL could probably just do it very fast.
So what's the Mongo secret sauce? Why pick Mongo? I still don't get it.
Well, okay, you have the ability I don't know whether you're on, if you take something like an Amazon product page on Amazon, for example. I don't know that they use Mongo, and they have their own alternative NoSQL database.
Right.
Well, but you have a hierarchical structure, you have all kinds of these tentacles, pull in the pictures, pull in the prices, pull in the deals, pull in the related products, you might want to look at all that stuff. So if you are using a relational hierarchy, pushing down through multiple levels of related tables, which may or may not have any data in, but you have to look. And then use that result to display stuff on the page. That's going to be much slower than having all that data in one object.
Okay.
And maintaining it. Maintaining it in the background with constantly running. They call it change streams, which monitor changes and then execute these triggers. And if that's available, then you don't need fourth normal form. If it's available in management, you don't need it from an equipment sheer performance. You've got solid state drives, you've got massively powerful processors that can do all of that and keep it all beautiful and maintain data integrity for you. So that is incredibly powerful.
Okay.
Now you see, I mean, if you're doing this in MySQL, and you would probably have a procedure that immediately someone asks for a page on the server side, it assembles it all into one object from all these tables and then delivers it. So you're not on the page, the HTML code isn't going to all these different places to find the stuff for you, or actually query on query on query. So, and you would use the kind of denormalization. If you think about the denormalization you're doing FileMaker to deal with that equipment testing problem, it's saying, hey, you could just specify that Mongo can do all that and do all the denormalization for you in a very structured, managed way, because for a lot of applications, denormalized performance is going to be essential or highly beneficial. And Mongo basically gives you a structure for doing that that's all laid out for you. Whereas in other tools, as far as I know, you have to sort of redesign that every single time. I think, anyway. Maybe people who see SQL databases more than I do would know different.
What, I'm sorry, I missed part of that question.
I think it was sort of why use MongoDB rather than the SQL backend as a new backend FileMaker.
Yeah, just the way that it's indexed. Now, I've had SQL servers where we needed to do searches on what we call a large area field, you know, quite a bit of data, and you have to index it, and it has to be predefined. It's not like FileMaker that allows you to unindex and, you know, index only when needed kind of thing. And but it's very fast. So that's what makes the SQL fast if it is indexed. With Mongo, just the way that it's designed, it's more flexible. And I know I've seen other presentations where you say you've got all your columns and rows, but if you've got spots where there's no data in it, in Mongo, you wouldn't even have that key value pair. It just wouldn't exist. And so your record is just the data you need.
Right.
Okay.
And you notice that in Terra Studio, you can just invent a new field right there on the form. Because you can just put another value pair in the JSON and it's there. Now, on that point, one just to go back to indexes, you can set up all the indexes you want in MongoDB. You do have to set them up explicitly, though. As far as I know, there's no automatic tuning.
Okay.
There might be. I haven't got that far yet. But with the ODBC driver, it's intriguing. If you it's to get the data structure for the table in FileMaker, it scans a certain number of documents in the collection to figure out what the column should be. And if in if a column you want isn't in that scan, it won't show up in the TO in the TO. And also if you so you can't create a sample with 3 or 4 records in it and use that to get things working with the ODBC driver if one of them doesn't have they don't have all the fields represented, all the possible columns, so-called columns represented. The other thing is if you truncate a collection and then query it with the ODBC driver, it just says no data source because the schema's gone with the data. And the only way I found around that was to remove the data source and do it all over again if you accidentally do that. So if you delete all the records in a collection and then query that with the ODBC driver before putting the data back in, it breaks the whole external data source. It kind of, it didn't occur to me when I did that, and I ran into that problem. There are ways, I think, to save the structure of a collection without any data in it. I'm not sure what that's called. There's a technique for that they have.
All right, any other questions for Oliver?
Paul Davis, I have one. Oliver, when you talked about updating, for example, a zip code, when you have the family embedded in the player, how do you handle? I'm not even sure how to describe it, but the equivalent of record locking in Mongo. I'm concerned about doing something like that and having the whole system freeze because one instance of the zip code can't be updated. Is record locking effectively document locking, or is it a field within a document that gets locked?
I do not know. Remember that comment I made earlier, the JSON you see is just like Plato's shadow on the wall of a cave.
Yeah.
highly structured, and it can maybe it queues it up to wait till the record's available. I don't know what would happen if you had if a user was looking at a player record while it with FileMaker it pushes it, just tells you, it updates it automatically. But
well, yeah, on FileMaker you can test for it too, and you can sit there and hang if you want, or you can forget about it and come back to it later.
I don't know actually how that would be handled. That would be a good question. I might look up.
Okay.
I would imagine that that's something that they've hammered out.
I'm sure, I assume so. And of course, when Claris implement this, we'll have push updates to users, of course, won't we?
All right.
Do watch the Hannah Gatsby special on Netflix, Douglas. It is as funny as any comedy session I've ever watched.
Thank you.
Good tip. Thanks.
Thanks, Oliver.
Before you go, let me Justin, I'm going to send you that PDF with all those links. If you could get that, I'm not sure where on my drive it is right now. If you could get that out to the group or make it available, I'd be grateful.
Sure, I'll send it out with the recording of this.
Okay, thank you.
All right.